Alright, so sleep physiology is a combination of a lot of neurotransmitters that are influencing you to either be awake or either to be asleep. So here I'm gonna start with the things that are keeping you awake, things that constantly keep you in that alerted state. Alright, so here we have a bunch of nucleuses and centers that are each contributing a unique neurotransmitter that is keeping you awake. So the first one that we can start with is histamine, being produced by the TMN. So that is the tuberal mammary nucleus, contributing histamine there. And then there we also have orexin, which is also called hypocretin, being released from the lateral hypothalamic area. Yeah. And then from there we also have a contribution from norepinephrine right about there. Norepinephrine contributing to, or being contributed by the locus coeruleus. So the locus coeruleus is contributing your norepinephrine, and then dopamine coming from the VTA, that's the ventral tegmental area, and then acetylcholine possibly coming from two sources where you have your so you have your PPT and then you have your LDT. So PPT, that's pedunculo-pontine tegmental nucleus. Then you also have the lateral dorsal tegmental nucleus, each contributing your acetylcholine, and then from there you have serotonin coming from the Raphe nucleus. So these are the neurotransmitters, and those are the nucleuses that are contributing to you staying awake. Now, sometimes we do have interactions among these same promoting centers. For example, orexin is known to be an influencer of you being awake. So it doesn't really directly act on the body, rather it's going to act on the TMN. And then TMN, apart from producing histamine, it will also produce GABA, and then this GABA is going to inhibit the sleep promoting center, which is the VLPO. So there is that sort of interaction. And then aside from this, we'll also see another guy coming into play, promoting you being awake, and this guy actually controls the circadian rhythm of you being awake. Alright, so this other guy who's involved in the circadian rhythm is called the SCN, the suprachiasmatic nucleus. So the suprachiasmatic nucleus is found in the anterior group of those nuclear groups of the hypothalamus. It's found anterior. So this one is heavily influenced by light, where during the daytime there we find him being active, and then during the nighttime he is inactive. So he has this interaction with the lateral hypothalamic area. He also has an interaction with the ventral lateral preoptic nucleus there. Okay, so we get to see that during the daytime, when he is active, he is going to inhibit the ventral lateral preoptic nucleus, which is a sleep promoting nucleus or center, and then it's going to stimulate the LHA, which is the lateral hypothalamic area. And then this lateral hypothalamic area, as we saw in the diagram above, it is going to produce orexin, or the hypocretin hormone. The hypocretin hormone, or the orexin, is going to act on the tuberal mammary nucleus, which is the wake center. It will promote wakefulness. Now, aside promoting wakefulness, this TMN can also inhibit the sleep promoting center. So there is that that balance, or that regulation between the sleep promoting and the wake promoting center. But during the nighttime, still during the daytime. During the daytime, this suprachiasmatic nucleus is going to send inhibitory signals to the pineal gland, and once it does that, the pineal gland won't secrete the neurotransmitter melatonin. Melatonin is actually something that promotes sleep. So during the day, the suprachiasmatic nucleus is going to send inhibitory signals to the pineal gland, preventing the release of the melatonin. But as you go to the night, you have less of the sunlight coming to your suprachiasmatic nucleus, so you're going to have less of activation of the lateral hypothalamic area, and you're going to have less of the inhibition on the ventrolateral preoptic nucleus. So when that inhibition decreases on this VLPO, it is going to promote sleep, and that activation on the LHA leads to inactivation of this guy, meaning less of the sleep. So we're going to promote more of the sleep during the nighttime. And aside that, the inhibition that we had on the pineal gland has also been removed. Therefore, the pineal gland can secrete the guy melatonin, which is also going to contribute to your sleep. So we see these two guys contributing to the overall sleep. Yes. And then from there we can switch to the the sleep promoting centers. The sleep promoting centers. So according to my research, I only found this one here, the VLPO, the ventrolateral preoptic nucleus. So this guy mainly secretes GABA, which is going to inhibit a lot of stuff, including the wake promoting centers. All those other different wake promoting centers are going to be inhibited by the GABA release by the VLPO. And then aside that, we're also going to see that we do have that molecule, adenosine. Adenosine is somehow going to more like stimulate the VLPO. So this adenosine is said to accumulate from the moment that you wake up. Like when you're from sleep, it's low in amount, but as you go during the day, it starts increasing in amount, and also as you do strenuous activities, it also increases largely in amount. So that adenosine is going to drive your body into that sleep state. So it's going to activate the VLPO, which is going to produce GABA, and then promote your sleep. So if you're beloved.